Good afternoon, everybody. It's Saturday, my friends, and I am back and ready to try and jump back into some try to jump back into some Java game dev stuff. So I've been putting it off a little bit here and there. But I think it's time that we tackle Vulkan. And I'm gonna use the example here from this Vulkan book. I'm going to try to follow this fairly closely because I've got no idea where to really start. So I'm hoping this will just kind of help me a little bit and, allow me to figure out what's going on. So that's my goal, hopefully, today. We're going to be doing a lot of jumping back and forth between code and not code. So I've got last time we worked out the keyboard stuff again, and that seems to be working a lot better now. So that's good. And what I want to do is I want to flip us back to the Vulkan engine here. It would be nice. Should I tackle that now or? I guess it wouldn't hurt to tackle it now. To just have a parameter command line argument to swap between the engines might not be a bad idea. Although I'll have to keep changing it when I go to run. It might not be worth it right now. Let's just go with commenting out and bringing things back in. I could do a simple one. Like I could bring in the command line parser. Is there an easy way? So there's program arguments. I guess I could have two run configurations. That would probably be the thing. Yeah, you know what? Let's just tackle this now while I'm thinking about it. Because we got the logger and stuff in there. Let's get the command line argument parser in now, because it'll be hopefully relatively simple. Is it? I think it's Apache Commons CLI. Is it? Apache Commons CLI. Is that what I used on? Wait, I used one on Magenta Breeze here. Let's go pull that. Not this one. The regular one. Here we go. Yeah, we might as well just use this again. Args for J. That's what it was. That. Okay, so then args for J, and then what, 2.37, okay. So I can bring that up here. Args for J. That's 3J. What? 4J. Huh. Wow, none of these links are working? Well, that's not good. This is not good at all. Huh. Oh, wow. I actually have a link to the Wayback Machine. Okay. Right. So it has option. Main args, command line parser. Oh, that's right. Yeah. I can do it with the annotations, which makes it a lot nicer to deal with. Okay, that's... You do have to pass in an object. My options. I guess it doesn't matter. It can just be a regular, just be an error class. Yeah, command line parser. Okay. Got it. Okay. I just wanted to get an idea of what the usage of it was again, because it's been a while. Alright, and we need args for J version up here. And what was that? Whoops, wrong way. What was the version number I was using? .37. Okay. 2.37 it is. Okay. So we have that in there. And I'll do a... Which one is it here? Maven sync. And I'll have it download the sources of documentation just so I have them. Okay. And then we'll go back to, so I can close that out. Go back to main here. And we'll just do class command args. Right, and how did I have it? At option, other command line parameters other than options. Okay. Arguments. So we just need the at option stuff. Okay. So we'll do. Are they doing them private? They are. It looks like they're doing reflection on it. Okay. Private string use engine. Say at option. Name and then usage. Okay. So we'll say E. Usage is what engine to use? OpenGL Vulkan. And then I think it said default here too. I thought this said had a default on it. I mean, I can give it a default just by initializing it, but yeah, I guess they just do it that way. Okay. By human readable description. I wonder if I can just look at it. Let's see what does it take. Name, aliases, which is a long option name. Usage. Okay, aliases, usage. Metavar. When an option takes an operand, the usage screen will show something like this. X foo. By using this parameter. Replace the foo token by using this parameter. Oh, I see. Okay. Required help hidden from the usage. Hands forbids. Okay, that's good. So help, specify the option as a help option when flagging an option being help option. Required arguments or options that are missing in an actual command line don't cause an exception to be thrown. Yeah, okay. Okay. So metavar can set that. All right, and then I'll just say equals 0 here, and Right, and then we just create it. So command args. Command args, and then command line parser. Okay. The fields are invoked setters appropriately. Okay. Okay. Parse argument, put that in a try catch. Got it. So let's do this. Let's do private command args parse command line. All right, and then what is it? CMD line parser. I thought it was. And it's just the parse argument that needs to be rent. Just catching exception. Command line exception. Jar my program actions of arguments parser print usage. Okay, and just continue without really failing it. I don't think there's any reason for me to just plain fail, just use defaults. What I'll do is system out ln unknown command line options. Using defaults. Okay, and then we'll just do What's going on here? Oh, because it's not static. There we go. I'm like, what is happening there that I can't do that? That's what's happening. Okay. If land args. Oh, I need a getter on that. Let's do this. Let's do. I'll put it in here. Public static final string. Use OpenGL. Use Vulkan. Okay, let's do that. Good. Okay, and then I can say come on. You can do it. Let's ignore case. Alright, then we do this. Actually, you know what? I should do this the other way around. I should default to OpenGL. Put that there, and then we'll say, say that, and then do that. Else, do that. Okay, that's a little bit better. Okay, so then, given that, I should be able to edit configuration, and we'll say this is GL, and then can I duplicate this? There we go. There we go. This will be Vulkan, and here we'll put -e Vulkan. All right, let's see if that runs. It does. Okay, that's got the Vulkan engine going. Cool. And if I switch to GL, yeah, we get our more fleshed out version. Okay, cool. That wasn't too bad. just to have a little bit of a little bit more, slightly more sophistication going. Okay, cool. So we've got that. So I got my Vulcan engine here. And so this is the engine. So the way they have it is they've got a whole instance going here. So, and then they've got render as a second thing. So the instance I'm gonna, I think, treat as the engine, because I know you can have multiple instances, but I feel like I only need probably one for my purposes. So that's what I'm going to do there. I just want to see if I can. I want to see if I can fit it into the same sort of mold that I have already. Although this is all like, this feels like it's all initialization stuff. And then what's the render? So the render is, okay. So really the instance is, the instance would be the window, right? So like I've got OpenGL window and I've got, this is where all the initialization and stuff happens in here. So I'm guessing that's kind of the same thing here. We got Vulkan window, which I think I just made a copy of the OpenGL window. But I think this is where I'm doing the vast majority of my stuff. So this has got the update and all that stuff going. So then but wait. Oh wait, they have their own window. Oh, okay. No, this is outside the normal. Okay, so I already have done this window here. Engine. Okay, so these are really, yeah, these really are, this really is separate. So where does this get pulled in as far as engine or window are concerned? So window doesn't pull it in. Engine doesn't directly pull it in either. Is it coming in from C? No. properties. Render. Render brings instance in. And render is called from engine, right? Yeah. Okay. That's how it's tied in. So the instance here is really a rendering instance. So I'm gonna name it that so I can keep it straight in my head at least. Okay. So we got an instance. Okay, so let's do, where are we at here with the packages? Fucking engine. All right, I'm gonna make a new package called render, just to try to keep these things together. And then we'll do Java class, and we'll say Vulkan render instance. Okay. And portability extensions, debug utils, message severity bit mask. Okay. Does that have to be public? Okay, public static file int message severity. VK debug utils. Where would that come in from? ext debug utils, maybe? Debug utils message severity error bit extension. Severity warning. So errors and warnings is what we want. What's going on here? No, whatever. Okay, so message type bitmask. All right. Message type general bit. Validation of performance. General. Performance and validation. Oh, what's the problem? It's more checkstyle stuff. Okay, so I have those. That's for just the debug messaging and stuff, right? Portability extension. Print static final string. Okay. Some of these, now the problem with some of these is I don't have the tools installed that I think makes those work. So it'll be interesting to see what happens there. Because I have a feeling it's just gonna crash and burn. VK instance. I'm assuming that's Vulkan instance. Yeah. Okay, debug utils messenger, create info. And the debug handle. validation layers and stuff. Set clock layers of. Huh. Let's see. Public instance Boolean validates stack push. And what are we doing with that? We're allocating application info on the stack. Okay. Stack push there and for app short name. Stack that. TF8. All right, so we have that, and then VK application info. Stack that. Colic. Oh, VK application info colic. S type. Structure type application info. Where does that come from? Probably VK11 or something like that. VK14. Structure type. Application info. There we go. Application name. Application version. What is this? Is this just saying my application version number? No idea. I guess so. Doesn't really say. P engine name, engine version. I think these are just my numbers. Or just engine version. API version. And that would be API version. I guess 1.1.2. Seems to be the biggest one I can do. Okay. Let's make this a little bit easier to look at. Alright, and then validation layers. So this is info. In here, list string validation layers get supported. Validation layers. Okay. So should only really do this if validate is turned on. Seems like. Number of validation layers. If supports validation. Okay. So do I actually use the validation layers? Is it actually used anywhere? That, yeah, that variable's not actually used anywhere. Okay. But we're calling get supported validation layers, which is a method we have to provide, apparently. So let's do... Let's do that and... Logger. Okay. And we'll just unable to create Vulkan render instance. Private get supported validation layers. I'm just noticing. Oh, you know what? There was no need for a catch. He's wrapped it in a try because it's auto closable. That's okay. So, I mean, I can keep the catch there, I guess. It's not hurting anything. But all right. Anyway, thought I didn't see a catch clause there. Get supported validation layers. It brings it back as a list string, but I guess it's more. I mean, I guess that's... It seems like all we're doing is looking at the number of validation layers that came back. I mean, I guess it doesn't hurt to bring it back as just a string list. Okay. memory stack going. Layers array int buffer. Enumerate instance layer properties. Okay. Oops. This layer properties. Property buffer. Oh, VK layer properties buffer props buff. Wait. Oh no. I'm looking too far down. Enumerate instance layers properties number of layers array. No. And then the number of layers is get 0 on there. Sorted validation layers. Okay. VK layer. VK layer properties. Where's that coming from? VK layer properties dot buffer. Oh, here it is. Layer properties. Buffer. Props equals. And we're just malloking it, right? No. VK layer properties colic. stack and then enumerate the layer properties again into the property buffer. Where do I have to do that twice? Does it say up here why they have to do it twice? Layers, for delivery. Okay. Forming, validation, okay. Get support validation layers. If we have requested validation, but have not found any layer that can help with this, log a warning to continue the execution. Yeah. We need to get the number of supported layers by invoking get layer properties function. This function receives two parameters: a number of layers and a pointer to a buffer that hold all the layers properties. This function could be using a total number of support layers and get their properties. We need first to get the number. So first parameter is to get an array, get the number of layers, and the second parameter is null. To get the properties, we will need to perform a second call to the same function once we get the total size. Oh, because we need to allocate enough buffer for... Oh, I see. That's why they have to call twice, because they don't know how many are there, so they have to allocate a number of a buffer that's large enough to hold the number of layers that came back, and then they can call it again to get to fill up the buffer. Okay. I see. I see now why it's done twice. Oof. Excuse me. Okay. Enumerate instance layer. So basically doing the same thing. This time we're putting it into props. Yeah. Oh, I see. They're just bringing the support layers back in order to debug log them. Okay. I mean, sure. Layer name, support layers that add layer name. Okay. Oh, no. We're putting them into a list of supported layers. Layers to use. And then they're just jumping out if it's if we have the Cronus validation or the Moonard validation. We're just returning that. Huh, okay. I see. So, number of layers, pros buff, get I, layer name string. So is there not a, because we're doing an old school for loop, which some of these things just require, but is there not a slicker way to do this? Supported layers. Let's see. String supported layers equals yeah, there is a stream on this. So stream map layer name map layer name to lists. I feel like I've done. Oh, layer name is a light buffer. Oh, layer name string. There we go. Okay. Okay, so supported layers. 2 lists. So it's a little bit cleaner. A little bit. We have the layers to use. Yeah, see, they do one thing here that I understand what they're doing, but I hate it. And that's the they've got requested layers here, and then they're adding a bunch of things to it, and then returning that. I guess I don't hate it that much. Yeah, I guess I don't. I guess it's not that bad. It's yeah, I think I see what they're going for. But I would do this ever so slightly differently. First of all, I wouldn't. It would be I would do a collections immutable list for that, and then pass that in there, which I guess we'll just do. So layers to use: main validation layer, fallback 2. Okay. So yeah, and again, the other thing here is, since we're returning directly from here, I wouldn't make a variable like this, right? Because I understand what he's doing, but it's, when you first look at this, it's a little bit confusing, because you're seeing layers to use here, and then all of a sudden you're seeing requested layers, and you're like, wait, what's going on down here, right? And it's more like, for me personally, if you're going to have multiple returns, like, you know, fallouts here, if you're not going to fall out of the method, instead you're going to like return early, which in this case makes sense, I would try to keep them self-contained and not reuse a variable here, because it's because then when you read it on your first reading of it, you're like, oh, this is an early out, this is an early out, this is an early out, you know, not a we're gonna fall through to the end and then take whatever's left over. I mean, that's as nitpicky as nitpickiness can be, but it's like, it's just something that I find works better for me when I'm like reading lots and lots of code. Like you just, there's certain patterns that just kind of that stand out enough to trigger your brain to say, whoops, something's not normal here, right? And it's not that it's not normal. It's not that normal's the wrong word. It's not that it's wrong or different to return early from a method. We do it all the time. It's just that many times when we're in a method and we're building up a list and returning that list, most of the time creating the list at the top, and then you're slowly adding things to it, and then returning that list at the bottom. If you're not going to do that, and there's a good reason not to do that here, you need to sort of break that default pattern that kind of goes into your brain as a developer and be like, no, look, this is something different. I'm not doing what you think I'm doing. And then that way, when you're trying to grok the method, you don't make an initial wrong assumption about what's going on. You see, oh, this stands out in my brain. This is different. Pay attention to this. You know, I mean, eventually you see what's happening, but it's like, it's not the first thing that occurred to me, right? Like the first thing that occurred to me when I saw this was, oh, all of these are going to add to the layers to use, and then we're going to drop out, but they don't. Like 2 of them do, but they drop out immediately. And then this guy doesn't even bother. So it's just kind of it took me a minute to wrap my brain around what was happening here. Now, I mean, again, there's nothing bad about this. It's a different style choice, you know? Anyway, so we're looking for these supported layers. So support layers contains that. I wonder if I can. No, I don't think. I don't think can I evaluate that now in a switch case? Because they've expanded switch case to do some of that stuff. I wonder. Java switch statement string contains. Years ago. Let's see if we can update it. Answer here. In Java 21, here we go. Case string S when S contains. Oh, okay. So you have to actually declare the variable. I guess that makes sense because it's kind of if you're going to use it, it has to be local scope, I guess. But I was like, I was pretty sure they introduced something like this now in the switch case, because the other thing about this is you can set this now, you can set a variable equal to the result of this switch case, which is what I was thinking in my head. Okay. Huh. I'm I'm surprised. But that's for... Oh, maybe that's why you have to declare a variable. Let's see what happens. I'm gonna try this. I've never done this before. So let's try it. So we gotta do... Where are we at here? Supported layers contains. Okay. So list string layers to use equals switch supported layers. I don't know if it likes that. Well, let's see. Case. String layer. Layer contains. Oh, it is working. Okay, contains. That. We want just want that back. List of does that, how's that? Let's see here. Statement must be prepended with a case label. Oh. I see what I did wrong. Okay. Does that work? Required type list provided string. Okay. Okay. Case list string. I thought it would have to be that. Layer. Layer. But it should be layers. Contains. Okay, and so the other one was this guy. And then default case is this. So I want to say okay. So I gotta add all of these. Let me just grab these in one shot here. What we'll do is we'll say lists of actually, you know what? Let me make this. Let me just make this a static list so it's even easier to see. Because I mean, why not? It's like it's never going to change, or if it does, you know, we're going to want to change the code anyway. Private static final list string. Validation fallback layers list of get these down a little bit so I can see them a little bit easier. Okay, there we go. Let me just say these. Back layers, stream, filter, to lists. Support layers, contains. Yeah. Does that actually work? Switch expression should produce result in all execution paths. Result of stream to list is ignored. Uh, saying the same thing for these, right? Ignore. Do I have to? I do a return on here? I forget now. I thought I'd just do it that way. Obviously not. Java switch statement return switch case return example. Yeah, they do use return. Oh, wait, no. That's the wrong thing. No, I don't want that. I want return value. Yeah, for direct return of value, break statements are not used here. Do I have to use? Maybe it's because I have. Oh, here it is. Yield. Yeah, because it's inside. Colon labels with yield keyword. One case requires more complex. You can use colon labels and the yield keyword to return a value. Okay. Okay. That's what I was looking for. So, because it's inside of braces, which technically I don't need the braces because I'm doing one thing, but yeah, that's what I need here. Well, I'm going to do it anyway this way. Okay, and then return letters to use. What's the problem here? Oh, yeah, that's right. It's true. It's not going to let me do this. Switch. Oh, check so. Yeah, that is true. That is redundant. Let's just do return. A little bit more compact and cleaner, I'd say. Oh, I am missing this other string though. This one. There we go. That's a little bit better. Okay. So that's the get supported validation layers. There's nothing else in there, right? Doesn't look like it. Which then pops us back up to all the way back up to here. All the way back up. This string validation layers. Back to no validation. So they're setting the supports validation equal to. It's just. Yeah. Okay. I mean, just set it here. Yeah. Like they're put it inside the if statement so they can put the logger warn there, which is fine. But you can still put just put an if statement and say if supports supports validation, then logger warn. You know, like this is needlessly verbose. So validation layers. And we say, so number of validation layers is used a couple different places to malloc. Okay. All right, so and we'll say Boolean supports validation equals validation ends. It's not equal 0. Yeah, does not equal 0. So since I'm combining them, I have to flip it a little bit. So it's validate and number of validation layers is not equal to 0, then it supports validation. Okay, if oh, I see. Yeah. That's right. No validations. You know, I also see why the way they had the debug message or the warning message. It was like, well, you asked for validation, but it wasn't available. Who cares? It's like you're the one writing the code. You know whether or not you asked for validation. So just putting a message saying there's no validation support is enough in there. Or even this debug message there. Set required layers. Is null unless supports validation is on. Okay. So we'll say required Set required layers. Pointer buffer. Required layers. Okay, number validation layers. It's number validation layers. I have a feeling I need to actually pass the validation layers in now, don't I? Yes, validation layers gets. Okay, so don't need the number of validation layers. Just list string validation layers. And what are we doing? Making the pointer buffer, setting it to null. Okay. Right? Yeah. And try. Oh, see, they're passing the stack in there too. Yeah. That's why they put it all in there, but okay, so we're saying, what are we saying? Malloc pointer. I can just do that here. Equals, because we'll set it to null otherwise, right? Like, I'll check the supports validation first. Or maybe I should, well, if the number, yeah, yeah, no, this is fine. This is fine. I'll just put it inside the if there. So, stack malloc pointer number of validation layers. So, malloc pointer size. Okay, required layers put I stack asking. Okay, so here I'm going to have to do the actual old school for loop because we have an index variable we have to put in there. I could do it without it, but it's still it's just cleaner doing it with that loop. Int I equals 0. 0I is less than so there's size I plus plus. Right. Required layers that puts. And then stack dot ASCII. Okay. Additional layer. Get I. Okay. And return required layers. So up here, we do required layers is null if supports validation. Is get required layers. Validation layers. What's going on here? Oh, and the stack. Okay. That in there, and then we're down to instance extensions. Get instance extensions. Where the hell is that at? Jesus H. Christ. Okay. It'd be down here. So it looks like basically almost the same thing that we did with the other thing, with the layers. So set string instance extensions. Doing a hash set though. Okay, so let's do this. I do, what was it? A hash set it's returning? Or just a set string. Get extensions. Set string instance extensions. Set and then return that. And it's in the right spot. Yeah, okay. So number extensions. So int buffer number extensions. Enumerate instance extension properties. Extension properties, and then null number extensions buffer and null. Oh, it's ambiguous call. That's why I did a cast to string here. Okay. And then number extensions buffer get 0. Okay. Extensions, number of supported. Okay. And then extension properties buffer. Number of extensions stack. Okay. So again, same pattern here. VK extension properties buffer. Number extensions stack. And then call it again with the null, and then the properties as the last one. Okay. Go. Okay. And then we're just looping over it, grabbing the extension names and returning them. Okay. So we want so we want set string supported extensions equals props stream map ek extension properties extension name string to, 2 Select collectors to unmodifiable set. Yes, I want that. That, and then supported extensions. Any of this, that just goes away. And yeah, we just return. Wait a minute, what did I do here? Oh, this is not right. Return extensions. There we go. That works. So then, where are we at? Wired layers. And then set string instance extensions. Okay, good. GLFW extension. If GLFW extensions is no, surface extensions, okay. All right. FW Vulcan. Get required instance extensions. Yeah, GLFW get required instance extensions. That's no, just throw new runtime exception GLFW. Extensions were not found. Okay. What else is there on that one? So then we have required extensions. So what are these? What are these? Is a good question. Layers. Now we set up the validation layer and move on to extensions. We'll create a method that will retrieve all the supported extensions. Okay. This method, as it will be frequent in many Vulkan API functions. First invoke. Yeah, okay. Go back to instance constructor because Vulkan is cross-platform API. Links to windowing systems are handled through extensions. Okay. In our case, we'll be using GLFW. Right. All right, I got it. Depending on if we've enabled validation or not, we'll need to add the extension used for debugging. We'll use the debug utils extension. Extension. Okay. Use portability. Portability extension and get OS is Mac OS. Just if we're on Mac OS and the VK KHR portability enumeration is available, we need to use that extension. Okay. I don't know that I care, but I guess it's worth putting. Like if I ever did decide to have this work on the Mac, I guess it would be a good idea to set that in there now rather than later, and then having to thumb through everything. Yeah, sure. I guess why not? Why not? What I'll probably do is move that to a private method though, so it kind of calls itself out a little bit. To be like, this is just for one specific operating system that nobody plays games on anyway. If they do, they just fire up Wine or a virtual machine. Because I'm definitely not going to jump through the hoops necessary to get it to work on the Mac. Not that there's that many, but just to create a binary, I'd have to have like Xcode installed, and you have to get a security key and all kinds of other absolute nonsense. And then I have no way of testing any of it, so I'm not really going to worry about it that much. I just kind of want Linux and Windows to work more than anything else. Okay, so that's getting the portability enumeration, and then get OS. We have an enabled debug. Callback. Start a new method. Create debug callback. Okay. Debug info. But they weren't kidding that Vulkan requires a feat of strength to get even the smallest of things going. Like, just to get, I mean, I had something loading up in OpenGL in like almost no time compared to how long it's taken to do the Vulkan stuff here. But I get it. It's closer to the bare metal. Still, yeah, and then so we have the debug stuff, and then yeah, this get OS thing, that's just like a general utility. That's not even really a Vulkan utility. That's just a Java, basically a Java utility, right? Because it's like just doing system get property OS name. and then parsing it, which I feel like there's a thing that does that already. Apache Commons operating system name. System utils. OS Apache Commons exec 140. Okay. Is family DOS? Is family Mac? Yeah. I mean, that's easier than reinventing the wheel, right? So I'm like, something like that. When you see this is the funny thing about stuff, right? When you see something like this, and it's using, system calls and whatnot, it's doing something that is pretty ubiquitous, right? It's like this is not the only case when someone's ever needed to know what operating system they were running on, right? It's like, instead of creating a utility class, just do a Google search and see what's out there. Because more than likely someone else has not only already done this, but did it better. You know what I mean? It's like, that's because I didn't even know. I was just thinking to myself, like, this is a common enough functionality that there's probably an Apache library somewhere that does it. And yeah, sure enough, boom, here you go. Apache Commons exec. System utils. Well, they're using Commons Lang system utils, but I'm pretty sure that has moved to, I think Apache recently did a thing where they pulled a lot of stuff out. Like, there was a lot of stuff in like string utils and all that stuff that was like adjacent to string utils and really could have been in its own package, and so they kind of pulled a lot of stuff out recently within the last few years into their own project. So let me see, Commons exec. Executing external processes from Java is a known area. Okay. Requires Java 8 or above. So let me see. Java doc. Commons exec. Yeah. OS. Copied and adapted from Apache Ant 196. Is family NetWare? Is family OpenVMS? Is family OS2? Holy hell. Now we're really Win9X. WinNT. Holy crap, we're going all the way back. And then you can do his name or pass all the stuff. Like, I mean, and you can even look for a particular version. Like, why not? What the hell, man? Like, why not use that? me see, what's the event repository? Do this. Commons exec. There we go. 1.4. And just come on over here. Oops. Too far down. There we go. There it is. All right, so we'll have that available to us. Even sync. And even download sources and documentation. Which is probably already done. Okay, cool. I'm going to stand up and stretch because I've been sitting for 2 hours here. And just take a short, like, 2 or 3 minute break. And I will be right back, my friends. Hang tight. Okay, I'm back. This back up here. Okay. Grab some more coffee too while I was out walking around. Let's see. What were we doing here? So we got the extensions. And now we are, I got this down. So we go back to here. Extension used for debugging. Okay. So down in chapter 2 here. So instance extensions, Panes portability, and Get OS is Mac OS. Okay. Supports validation. Hard extensions. Put portability extension. Hard extensions put, and then put. I see. Okay, they're building up a full buffer of things. Okay. So I definitely want to pull this out into a method. I'm trying to see where I want to pull it though. So supports validation, probably everything within the supports validation. And subset PK KHR. Okay. Static dynamic pointer, number extensions, number extensions put. LFW extensions. No, I gotta do. Oh my god. They're just looking for if the use portability is there. You know what? I'm gonna. So the use portability is only needed there, right? So I'm going to take this entire block. and just make it a method. Yeah, I'm just gonna say get required extensions, because that's just like there's just some silliness in there as far as like having all those variables as local variables within the larger scope. It doesn't really make a whole lot of sense. Are they doing stuff on the stack here? They are. Okay, so I gotta pass the stack in. So we'll say private pointer buffer get required extensions, and then memory stacks stack. Okay, so pointer buffer required extensions. They don't even set it to null, they just create it. And then I'm going to set it to null. just so it's happy about it. And then I gotta pass in the instance extensions. So we'll say set string instance extensions. All right, and that is contains portability extension. Where is that defined? Oh, actually, we've already defined that. Okay. Portability extension and OS is family Mac. Oh, simple. Supports validation. I need to bring that into. Okay. Byte buffer VK debug utils extension. Stack UTF-8. Okay. Where's this other thing? ext debug utils. Debug utils extension name. Number of extensions equals if use portability, then glfw extensions dot remaining plus 2, otherwise GLFW extensions dot remaining plus 1. Okay. Equals that was not it. Oh yeah, no, that is correct. Need the GLFW extensions too. Oh, this is a pain in the ass. That's remaining plus 2, otherwise the extensions remaining plus 1. I like pointer. Okay, required extensions. And then require extensions put GLFW extensions VK debug utils extensions. What was it? Put GLFW and then the other one. If use portability. Was it required extensions? Put stack UTF-8 portability extension. Else, number of extensions equals use portability plus 1, otherwise remaining. Okay. And then, select the pointer, and then just put the GLFW extensions in there. And if portability, grab a different thing. And this is what? KHR portability subset. VK KHR portability subset extension name. There we go. And then flip the pointer buffer. Okay. Return that. So get required extensions. Extensions, and then we need instance extensions, supports validation, GLFW, and then stack. Okay. Long extension equals retail null. Supports validation. Create debug callback. Otherwise, debug util or create debug callback and debug utils dot address. Debug callback. Where is the create debug callback? Oh, here it is, right in front of me. Oh, it's just a okay. It's a big old return statement. I got it. Okay. VK debug utils messenger create info. Info ext? Yeah. Great. Debug callback. Return, okay. type. Okay, VK. Where's that coming from? VK structure type debug utils. It's probably VK 14 VK structure type. Structure type debug utils. Okay, so it's not from there. It's not from there either. All right, where would this come from? VK structure type debug. Maybe it's ext debug utils. Yeah, here it is. Structure utils. What is that? Where am I at? There we go. VK structure type debug utils messenger create info. ext. Message severity. Message type. Message type mask, right? And user callback. What we got there? Message severity, message types, P callback data, user data. So user callback data, user data. Severity message types. Okay, I'll just do that. VK debug utils messenger callback data ext creates. Oof. Info. Messenger callback data. Messenger callback data ext. callback data. Let's that create from the pointer to callback data that we get. Info warning error. Oh, we're just mapping. We're mapping the. Let's see what's happening. We're mapping the Vulkan. The Vulkan debug util message severity to our own logback logger. So it shows up in our logs with the correct. It shows up in our logs with the correct severity. And we're doing, okay, and we're taking the message severity and doing a logical AND. Or, I'm sorry, a bitwise AND. Not, logical AND is 2 ampersands. A bitwise AND against the particular bits. Okay. Ooh, sorry, I'm very yawny today. So what I can do I wonder if I can do that. Well, I guess let's try this. This will be an interesting test here. So switch on message severity. Case, is that an int? So int severity when severity and VK debug utils message severity info warning error. I guess I gotta do just for my benefit than anything else. Does that work? Acquired Boolean. Oh, duh. Not equal 0. Does that work? Primitive types and patterns, instance of, and switch are not supported at language level 21. Okay. Yeah, I mean, that makes sense. Yeah, okay. I thought I'd try it, but it's not. It's not a thing right now. Better. That's a little bit better. What's going on? Missing. Oh, missing return statement. Okay. I don't know what it was complaining about. Okay. Info warn and then error. String. P message string. Callback data P message string. Okay. Else if and this should be warning. Warning and then error. So the error there. We have an else here too. What's that? Just debug. Okay. this is logger warn logger error. And then just logger debug. And then return VK false. Return. Okay. Use that. Try with resources. Damn it. Yeah, that's fine. Yeah, we're good there. Create debug callback. So I have to go. So we're up here. Wrong extension. This is really just a debug extension, right? Yeah. Where's that even used? Extension? Oh, it's using the create instance info. This is really, so it's really a logging extension. If support validation, utils equals create debug callback extension equals debug utils dot address. Okay. And So VK instance create info. We just create an thing, or we created application info, and now we're creating instance information. Okay. VK instance create info. Info equals create info call stack. Oh, what am I doing? What am I doing here? Clock stack S type. Structure instance create info. Hopefully VK structure type instance create info. Okay. Next. Logging extension. Application info. PP enabled layer names. Required layers and required extensions. Okay. And this is required extensions. Required extensions, okay, and then if use portability. Oh, so we actually have the use portability down here, really? What is that doing? Instance info flags. So one place where I needed that use portability. Fine. Sports validation. Let's say Boolean use ability mention. Okay. And then up here on this one, right in there. So then for this one, this is info. Instance create enumerate. Isn't there a thing to set that? Okay. So does that not exist anywhere? Okay, KHR portability enumeration. Provided by VK version. Oh, it's in VK instance create flag bits. VK instance create info flags. Okay, instance create flag. Instance create. I guess they don't have them enumerated. Layer count. Interesting. I'm going to put this up here so we have it. Okay, so we have that set there, and then what else? We gotta get a pointer buffer to the instance, malloc that, and then actually create it. Okay, so pointer buffer instance. Instance buffer equals stack malloc pointer 1. VK check. Warehouse VK check. VK check. Oh. Vulcan utils VK check. Was that the utils that they create? That's something they created. Vulcan utils. VK check. Here we go. If error does not equal VK success, runtime exception. Oh, it's just okay. An error string error message. I see what they're doing. Error create instance. I'll just check return, I guess. Let's do new package. Let's do private public static void, right? Fail if needed. And we'll do int results code string error message, and this will just do if result code. And we'll say does not equal Q14 dot okay success throw new runtime exception error message. There we go. If needed, and then we're doing what? VK create instance. Instance, and what's that? Create info, allocator, and then instance. So instance info null instance. And then oh, PS, so instance buffer. Create instance. Okay. VK instance equals new VK instance. VK instance, instance get and instance info. Okay. Instance buffer.get and instance info. Okay, and then debug stuff. Debug handle is null handle. Is that, what is that? Oh, that's the VK. Did I not create that? VK debug handle. Oh yeah, I think I forgot the private long VK debug handle. Oh, I just called it Vulkan debug handle, which makes more sense. Equals VK null handle. Null handle, if supports validation. Malika long and try to create the debug utils messenger ext. Okay. Stack that malloc long and mail if needed, and this is vk14.vk create debug utils. I'm guessing this is in the other thing. What's it called? No, why is that doing star imports? Stop doing star imports. God damn it. I've turned star imports off. Why is this doing that? I freaking hate this IDE. I really do. Like, you turn something off and it just keeps on doing it, even after you turn it off. I want actual settings here. Let's star. Where's the imports? Imports. Use a single class import. Like, how many frickin' times do I have to say that? Oh, here it is. Class count to use import with star. That's what's doing it. Freaking hell, man. Names count to use static imports. 999. That's what's doing it. That drives me absolutely up a frickin' wall. Jesus Christ. Yeah, let's just include the entire effing Vulcan package when we don't need it. Oh, man. Say what you will about Eclipse, but when you turn something off, it stays off. There's not 900 other things that will turn it back on again. So, I'm guessing you gotta do ext debug utils. Maybe? Create debug utils. Messenger ext. That's what it is. Instance, so VK instance, debug utils null. Wrong buffer. Debug utils. And then debug handle gets that. Okay, put the 0 there. Yeah. Although I suspect calling it without a parameter is doing the 0th position, but just to be all on the safe side there. Okay. So all of that, we finally finished the constructor. After all that, finally finished the damn constructor. That was what? 3.5 hours of just writing that effing constructor. Holy crap. And that's just, we're not even an eighth of the way towards getting something to show up on the Vulcan engine. Okay. And then, so create debug. So the only other thing I have to do here is the cleanup. All right. VK debug handle, null handle, destroy debug utils, destroy instance, debug utils is not equal no. Okay. So public void cleanup. And VK debug handle. Not equal. Oh, does not equal UK team. Okay, I'll handle. Destroy debug utils messenger ext. So and that takes instance debug handle. No. Okay. All right, and then K14 dot K destroy instance, and that takes the instance and null. And if debug utils is not null, debug utils user callback free. And debug utils free. Okay, so there we go with that. I think that was everything there. Just get instance, get VK instance. So just a getter on that one. Let's go on here. Oh, it's just a check style thing. VK must match pattern. How does it not match the pattern? A to Z, A to Z, A to Z, 0 to 9. Am I missing? Oh, wait. Static file. There we go. I am missing something. Like, wait, something's not right here. Let me put this down the bottom. Why not? Getter for VK instance. There we go. Okay. That's one class out of 2 done there. So we just have the render, which looks pretty clean here. I mean, all that's really doing is referencing the instance. It's creating the instance, and then what the hell is engine properties? Get instance. Oh, it's, what are they doing in engine properties? Get resources stream, file name, load. Props, get or defaults. Default UPS, VK validate. They're just reading a properties file, engine.properties, which I'm not. I mean, I'll have a properties file eventually. but all that's doing is the updates per second and whether or not to set the validate flag. Whoop-de-doo. Whoop-de-doo, I say right now. Those are easy enough to externalize later. So all that's really doing, so engine properties we don't give a flying hoot about right now. So all render's doing is taking in the window and the scene, which I do have a scene object, but I don't know if it's going to work the way I want it to work right now. And then it's not actually doing anything. It's not actually rendering anything, but it's mostly just building the instance. And scene, they don't have anything in scene yet. I wonder if I can use the scene that I already have. I would like to use the scene I already have, if that's even possible, because I would like to reuse all that stuff if I can. I've got shaders and stuff here. Shader uniform matter. I would imagine most of these probably are still good. Like the model loader and stuff is still probably fine, because it's loading up all the meshes and stuff. Now, model renderer is probably not going to work, right? Because I'm using GL. Yeah, I'm doing GL vertex shaders and stuff. So that's probably the thing that's going to have to change. I think all the uniforms and stuff are probably okay. But yeah, this is referencing GL46. So this is really that should really go under the OpenGL engine renderer. I mean, this is good. This is why I wanted to do the Vulkan stuff right now. One is I haven't gotten very far, and two, this allows me to sort of start to look at all the things I've kind of, not necessarily hard-coded, but the things I've done to get the OpenGL stuff to work. And now I can start to move things around to places where they actually make more sense. Like this renderer is definitely an OpenGL thing, so that should probably go under my OpenGL engine here, right? So put that under there. And again, I mean, it's gonna have other. I mean, eventually we're gonna do even more changes to that, because right now it's rendering just one object. It's not rendering an entire scene, which is eventually what we'll want to do, like multiple objects and stuff. So I'm just iterating on what I've got right now. Just so I want to work on one object just so I can see what that looks like, and then I can start to build up from there. So the model loader, I think, is fine out in generic land here, asset generic land. Mesh is not. Yeah, mesh is not. Material. Material's okay. I think, yeah, material looks okay. I don't see any... Yeah, we're just using Jomal, so that should be fine. Entity? Yeah, entity should be fine. And then camera... Yeah, camera will be fine too. Like, I figure most of the math-y stuff is probably portable between the two engines. Probably stay up in the generic packages. Generic, quote unquote. It's just the where the rubber hits the road, where you're actually taking that stuff and doing communicating with the engine. That's where we gotta so like the renderer and the mesh is doing, what is that doing? Yeah, so that's like generating vertex arrays and stuff. Although I guess in reality here, this is probably going to be the for starters, I'll probably just copy paste, right? And then change things around to the appropriate thing. But I think ultimately for something like mesh here, I don't know. Maybe enable vertex array. I think okay. Maybe there will be like a OpenGL mesh class versus a Vulkan mesh class, and then probably what I do is turn this class into an interface. And then we just call, and then based on whatever engine is fired up, we'll call whatever implementation is correct for the engine. Although I don't, how much of this would be actually useful as an interface? Because there may not be a concept of a VAO ID or VDO ID list. So yeah, this might be just an entirely engine specific thing. Which is not necessarily a bad thing. I mean, this feels like one of those methods where you kind of write it once and then all you ever do later on is just small tweaks. So, and I'm assuming those small tweaks will be based on the actual, will be different based on the engine probably. So I think the best way forward is to just, for starters, just copy the class, right? So move this mesh class into the OpenGL engine, call it GL mesh or something, or OpenGL mesh, then make a copy of that, put it in the Vulkan engine, and then call it Vulkan mesh, and then change it around to what is appropriate for the Vulkan stuff. If there may not even, like I said, there may not even be I mean, there's probably a concept of it, but who knows what it's going to look like. Yeah, and I mean, I'm going to follow the book that we're looking at, the OpenGL or the Vulkan book here that we're looking at. Go. I guess we'll go kind of chapter by chapter. Although I got to figure out, like, there might be some chapters in there that I don't need right now, kind of thing, or I might have to skip around a little bit. We'll see. Yeah, so their scene is not filled out yet, so that's why they don't have like the mesh or anything else yet, probably, and shaders and all that. Yeah, I might end up. I mean, that's what the safest. I guess the safest thing right now is to. No, well, I'll figure it out. I'll figure it out as we go. Like if there's like the render class, we know is definitely going to be different between the two. So I can always work on that. And right now it's just create an instance, take the window in, take a scene in, which the scene doesn't have anything in it at the moment, so I don't need to do that just yet. Yeah, so final instance render. So if I just do, let's see here. Render instance, and then new class render. Right, and then final instance. What? Public Vulkan renderer Vulkan window equals new Vulkan render instance. False for the moment. Okay, and then they just have a cleanup and the render itself. Okay, and then for the engine, what did they change there? So calling So render, private final render, okay. Private Vulkan renderer. Should get rid of the model renderer then. Which I had there just temporarily. Oh, yeah. Well, these don't make any sense right now. So let's just get those out for a moment. So renderer is new render window scene. So I have that in init, right? Yes, we have this here. Vulkan window, render, new render. Go. All right, and then clean up. It's calling renderer cleanup now. Addition. To window cleanup. Good. And I guess I leave the rest the same for now. Render window. I can call it at least. Yeah, why? I'm just, there's no reason to keep passing the window in, is there? If this was the other thing, like they're constantly passing this window in, and I'm like, when's that going to change? Like, I guess if you had a multi-window app, it would make sense, but like, for me, that's not going to change as far as I can tell. So let's just do this. Private. Window. Just get rid of it from here. Start, stop, and then did they do anything to change anything in window here? guessing no. Let's see, layers. Fallback. Market details. King instance. A new thing. That's all. Can you use the instance class or render class and constructor and cleanup methods? Yeah. Okay, so nothing else. Look like. Guess we can try it, even though it's not going to show anything, as far as I can tell, anyway. Let's try this. Vulkan. If it even compiles. Okay, I mean, it's still showing nothing. Which is correct, although it isn't, it's also not handling the escape key. So, did I not wire that up? No, I have it on here. Got window signal closed. Maybe I don't have anything in there. Huh, that's a thing. Okay. I mean, it's not any worse than it was. So I guess, you know, if the keyboard stuff's not working, we'll figure it out. But at the very least, we've done chapter 2. We don't have much to show for it, but we've done it. So that's good. Then what's chapter 3 looking at? Physical device selection. Right. So this is another thing we have to wire up. So I mean, that's one of the things that was told to me, is that there's a lot of before you can get anything on the screen in Vulkan, there's a lot of setup. And chapter 3 has got a ton of stuff. Surface, cues, and rendering modifications. And then what do we do in chapter 4 here? Swap chain. We'll continue our road to render on the screen. Jesus Christ. All right. 2 edge 3. Swap chain. Yeah, so it's like triple buffering, double buffering. Really, it's just swapping out the what's in memory with what's displaying on the screen. I mean, normally games will create the visuals in an off-screen buffer and then swap that buffer to the screen that's actually visible, to the buffer that's actually being displayed, and then write the next frame to the off-screen buffer, and then swap it back. So it just keeps, it's just a pointer that just keeps going back and forth basically in memory, between the surface that's being shown and the surface that's being written to. And then double buffering is you write 2 frames basically off screen, and then start to swap between those, and then that gives you, in theory, it gives you enough time to get a full frame done. But it's not as big a deal now as it used to be. I mean, it's still a thing that's employed, but it's not as crazy now because the processors have a lot more power. So this is doing swap chains. Okay, and then what's chapter 5? Where do we actually get to, like, loading models and stuff? Clearing the screen. That are required to render a scene to the screen. We'll finally combine all these concepts with element described. Okay. Render pass. So this is actually creating probably a black screen. After everything else. Frame buffer. Command buffers. Synchronization. Oh god, we're getting up in the semaphores. Yep. Yep. Put it all up together. Render. Swap chain. Synchronization. There it is. So by the end of chapter 5, we'll actually have a window that isn't transparent. It will actually have a blank background on it, colored background. Holy crap, that is so much freaking code you have to write just to get to that point, but I get it. I get it. It is what it is. So then I am assuming chapter 6 starts to look at shaders and loading, or, well, okay, drawing a triangle. We could probably, I mean, we'll need some of this, I'm assuming, for text description, but really, we want to load a model. We don't want to just, yeah, here we go, go in 3D. We'll be rendering a 3D model in chapter 7. Depth image. Oh, they're creating the image themselves. Attachment. Lucy structure. Depth testing. And then the shaders, putting it all together. Complex models. Here we go. Chapter 8. This is where they're actually loading models up. Okay. So I'll probably, once we get to like doing, once we get to chapter 5 where we actually get something on screen, a black screen there, I'll probably jump ahead to chapter 8 and just take a look at all of this together. Because I've got a model loader and everything already. So I don't think I need to change that. I mean, this is looking basically the same. Textures. STB. What? Why are they bringing in? Oh, I'm already bringing that in though. That's just to load PNG files and stuff. Yeah, STB. Yep, all that stuff. I got all that stuff already in place, so that's good. And we know it's working in OpenGL, so it's got to work elsewhere too. Now see here, it's got Command copy buffer to image. That has me mildly concerned that we're having to do different things for that, but we'll have to see. The model, create indices buffers. Well, this is really, well, this is my load model stuff, which I already know is going to be different. Descriptors, uniforms, yeah, here we go. Yep, okay, so chapter 8 is where we want to get to. It's going to take us a bit. We've only just completed chapter 2, but take us a bit to get there. But once we're there, we'll probably be like pretty much on par with where we're at with the OpenGL engine. So that'll be good, and then we can compare and contrast and see how these two things are going to live side by side in the same package. I know it's possible because others have done it. So we'll see. Yeah, and I guess I'm wondering. So so starting up, I'd probably start up by default. I'm thinking about like the options menu, which is another thing we'll have to do eventually. But I'm thinking when you start up the game, it'll probably start up with OpenGL as the default. And then in the options menu, you could switch over to Vulkan engine. And then I would have to figure out a way. I mean, basically, I would just have to call, I guess, clean up on everything, close the window, and then reopen the window with Vulkan, which in theory I could do because all I have to do is just call cleanup on everything. In theory, and then make just have to have the window. We'll have to figure out a way to like close the window without killing the entire app in the process. I think it already is happening. It's just there's nothing happening after the window closes. So I think I'll have to see. I'll have to see how that works. So that would be a thing. But anyway, cool. Very cool. I think we can take our stuff right now and commit. Let's do git commit directory, and I want to say change engine type via command line args and finished chapter 2 of Vulkan book for engines. Okay. And push. There we go. Cool. Cool beans. All right, my friends. I am getting a bit hungry. It's going on just over 4 hours of stuff here. So I am going to buzz off and do my own thing. I don't think I'm going to stream anymore tonight. Question mark. I don't think I am. We'll see. Maybe I'll jump on and play a game or something, play Torchlight or something like that. I don't know. We'll see. I right now I just have to get up and move around, and I have to go around and get something to eat and all those things, and then we'll see how I feel after that. I'm actually not like tired or anything. I'm just all cramped up right now after sitting here for this long. I try to, like, during the day when I'm working, I try to I use my desk more often, where I'll put it in standing mode and I'll stand for a little while. The only reason I'm not doing it on stream is because I'm tall, and so the camera is not. I still have not figured out where I can position the camera and such that it will always work, even when I'm in standing. You know what I mean? So half my head will be cut off. You'll see just a floating mouth. So that's the only reason I don't do that right now. But we'll see. We'll see on all those things. Let me see if I don't think there's anyone streaming right now, but let me just take a look. Nope, I don't see anybody. Okay, so I am going to stop right there, my friends, and I'm going to say thank you so much for watching, everybody. If you do happen upon this on the YouTubes and you want to do me a solid, a like and or subscribe would be rather awesome. Not required, but awesome nonetheless. Otherwise, thank you so much, everyone, for watching. I hope everyone has an excellent morning, afternoon, or evening, depending on what it is for you. And I hope to see you back here again in the future for some more stuff, whatever happens to suit your fancy. Until then, see you, bye.
Space!